You're welcome to our YouTube channel. In today's video, I will be dealing on calculation based on formula mass. Calculation on formula mass. Now, in most cases, this can also be considered as calculating the relative molecular mass of a particular compound. So let's get started. You might have a compound like this, CO2. Here's number 1. Here's number 2, CO. Number 3 should be N2O. Number 4, H2SO4. Number 5 is let's say NO3 2 minus. If you are told to calculate the formula mass of the following, if you are asked to calculate the formula mass of the following, what you are expected to do is very simple. This is a question you likely see in your Jamb. But the truth is that this is the simplest part of it. This is just a step to the one you are going to see in your Jamb examination. So let's get started. If you are told to calculate the formula mass of CO2, the first thing you have to think of is what is the atomic mass of carbon and of oxygen. So the individual constituents of a particular compound, you have to know the atomic number first, the atomic mass, before you can calculate the formula mass of it. So we all agree that the atomic number of carbon is 6, while the atomic mass of carbon is 12. We have hydrogen, helium, lithium, beryllium, boron. Carbon has the atomic number of 6, but the atomic mass of carbon is 12. So we have 12 plus, let me give you the first step, carbon plus 2 oxygen. So from there we can say carbon is 12 plus 2 times 16, because we have 2 oxygen here. So that will give us 12 plus 2 times 16 will give us 32. Yes, 2 plus 2, we have 4. Then 3 plus 1, we have 44 gram per mole. So for CO2, the formula mass of CO2 is 44 gram per mole. So let's try the one of CO. So if you have CO, you are going to have C plus oxygen. Assuming we have 2 CO is a different case. You multiply your whole stuff by 2. So carbon is already 12 and oxygen is 16. So if you add 12 plus 2 plus 6, we have 8, and 1 plus 1, we have 2. So we have 28 gram per mole as the formula mass for CO2. Then a question might also come in this format for CaCO3. This is limestone. Calcium already is 40, carbon is 12, and oxygen is 16 times 3. Oxygen is 16 times 3. So we have 40 plus 12 plus 16 times 3. So we have 48. Then 2 plus this will give us 0, which is 10. Then at the end we are going to have 60 here. 60 plus 40, we have 100 gram per mole. That is for CaCO3. So if you have something like N2O, N2O will give us nitrogen is 14 times 2 plus oxygen already is 16. Then here you are going to have 28 plus 16. 6 plus this we have 4. 2 plus 1 we have 44 gram per mole. So this is just how you are going to calculate the formula mass of a particular compound. Then if you have H2SO4, let me try. This one is kind of complex, which is NO3 minus, please, not 2 minus, NO3 minus. If you have a compound like this is a radical, this is a charge, this is an anion. If you have a compound like this, it's still the same thing. Nitrogen plus 3 oxygen. So it's just for you to write nitrogen is 14, 3 times 16, that will give us 48 plus 14. 8 plus 4 will give us 2. Then 4 plus 1 plus 1 will give us 62 gram per mole. So this is how you calculate the formula mass of a particular compound. But Jamb may likely not give you simple question like this. They might extend your work to calculate the percentage composition of nitrogen in this compound, or the percentage composition of let's say of carbon in this compound, or of calcium, carbon rather in this compound, calcium in this compound, they might tell you to calculate the percentage composition of any of the elements. But for Waec won't tell you to calculate one. In a theory question, it's going to tell you to calculate all of them. But for objective, Waec might ask you to calculate just 12. So for H2SO4, I want to do the one of sulfuric acid. The answer should be 98 gram per mole. If you have this as your answer, that means you are correct. Thank you for watching. Stay blessed.